Good morning. Let us continue with the topic nucleophilic addition reactions. In the last class I told you aldehydes and ketones they undergo nucleophilic addition reactions. Again, out of aldehydes and ketones, aldehydes are more reactive towards nucleophilic addition reaction compared to ketones because of two reasons. One is steric reason, other one is electronic reason. So today we are going to discuss different nucleophilic addition reactions. Let us discuss it one by one. So first nucleophilic addition reaction, that is addition of HCN. Addition of HCN. HCN means hydrogen cyanide. Hydrogen cyanide. So addition of hydrogen cyanide or addition of HCN, hydrogen cyanide. Now aldehydes and ketones are generally carbonyl compounds. They undergo addition reaction with hydrogen cyanide. Aldehydes and ketones react with hydrogen cyanide forming an addition compound. That addition compound it is called formed product, it is called as what? It is called as cyanohydrin. Cyanohydrin. So aldehyde reacts with HCN forming cyanohydrin. Ketones also react with HCN forming what? Forming cyanohydrin. But the reactions of aldehydes and ketones with pure HCN, reaction of what? Aldehyde or ketone with pure HCN, it is very slow. Rate of the reaction it is slow, very slow. With what? With pure HCN. So aldehydes and ketones react slowly with what? With pure HCN. So in order to increase the rate of the reaction, a base is added. It is added, role of a base here, it acts as a catalyst, So reaction, it is catalyzed by a base. I will repeat it once again. See, aldehydes and ketones react with what? With hydrogen cyanide forming a product. That product it is called as cyanohydrin. Aldehyde forms cyanohydrin, ketone also forms what? Cyanohydrin. Ketone also forms cyanohydrin. Next, what I told you, reactions of aldehydes and ketones, it is very slow with pure HCN. It is what? It is very slow with pure HCN. So reaction it is catalyzed by a base. So role of a base here, it acts as what? It acts as a catalyst for the reaction. Let us write the equation. Aldehyde or ketone, generally we write it like this. It is C double bond O. C double bond O represents either an aldehyde or a ketone. Now this aldehyde or ketone, it is made to react with hydrogen cyanide. See, hydrogen cyanide, it ionizes to form what? To form H plus N Cn minus. H plus N Cn minus. Now what about carbonyl group? In this carbonyl group, carbon it is directly bonded to what? Bonded to oxygen by a double bond. So here what happens is, since it is more electronegative, to attract the shared pair of electrons towards itself. So oxygen tries to attract the electrons towards itself. As a result, oxygen will be carrying partial negative charge, carbon will be carrying partial positive charge. So carbonyl group it is polarized. Carbon carries delta plus, oxygen carries what? Delta minus. Now this electrophilic center, carbon it is carrying positive charge, so it is electrophilic. This electrophilic center, it is readily attacked by what? By the nucleophile, that is Cn minus. So Cn minus acts as the nucleophile. It readily attacks what? It readily attacks positively charged carbon. So once it attacks positively charged carbon, already there was partial transfer of electron. Now electrons will be completely shifted to oxygen. Electrons will be shifted to oxygen. As a result, oxygen gains what? Complete negative charge. Complete negative charge. So after gaining complete negative charge, it will attract the positively charged species, that is H plus. That is what? That is H plus. So I'll write the product here. Reaction, it is catalyzed by the base. Carbon, it is attacked by the nucleophile, that is Cn minus. So electrons will be shifted, means double bond gets reduced to single bond. This O minus readily accepts H plus, forming OH. Forming what? Forming OH. This product, it is called as, this product, it is named as what? It is named as cyanohydrin. Named as what? Cyanohydrin. Now let us write the mechanism of this reaction. Mechanism of this reaction. Mechanism. See, in the first step, hydrogen cyanide readily reacts with what? With the base. Hydrogen cyanide readily reacts with the base, thereby it helps in the cleavage of hydrogen carbon bond. Helps in the cleavage of what? Hydrogen carbon bond. As a result, we'll get what? We'll get Cn minus along with OH minus readily accepts H plus. This is H plus. Cn minus readily accepts H plus, forming H2O. So no need to write the charge here. So HCN combines with the base, forming Cn minus. Cn minus, what is this? Nucleophile along with what? Along with water, H2O. Along with the water, H2O. Next step. This is also reversible only. In the next step, carbonyl compound, that is aldehyde or ketone, it is attacked by the nucleophile. Attacked by what? Attacked by the nucleophile. Here, carbon carries positive charge, oxygen carries negative charge. So nucleophilic attack takes place upon carbon. Upon what? Upon carbon. Negatively charged species always attacks at the positive center or electron deficient center. So here, carbon, it is electron deficient. So nucleophile readily attacks the carbon. So once it attacks the carbon, electrons completely get shifted. Shifted to what? Shifted to oxygen. So we'll get an intermediate. This is Cn. Double bond becomes single bond. O minus. Single bond O minus. This is tetrahedral intermediate. Tetrahedral intermediate. So upon nucleophilic attack, hybridization of carbon changes from sp2 to sp3. In the next step, this alkoxide intermediate readily accepts the proton, or readily it picks up a proton from the medium. From what? From the medium. Medium contains what? Medium contains water. Water ionizes to form H plus and OH minus. So it will accept H plus from the medium, forming C. This is Cn. Single bond O minus becomes OH. O minus becomes what? Becomes OH, this is cyanohydrin. So this is the mechanism of addition of HCN. Mechanism of what? Addition of HCN to a carbonyl group. Addition of HCN to an aldehyde or ketone, or addition of HCN to a carbonyl group. Important for 2 marks. Explain the mechanism of addition of HCN to a carbonyl group. Next, second one. Addition of sodium hydrogen addition of sodium hydrogen sulfide, that is Na, sodium, hydrogen means H, sulfide SO3, addition of what? Sodium hydrogen sulfide. It is also called as sodium bisulfite. Also called as what? Sodium bisulfite. Let us explain this reaction. Addition of sodium hydrogen sulfide or addition of sodium bisulfide to a carbonyl group. See, aldehydes and ketones, they react with what? With sodium hydrogen sulfide, forming an addition compound it undergoes addition, forming an addition compound. This addition compound, it is called as bisulfite called as what? Bisulfite addition compound, and this compound, it is crystalline in nature. This compound, it is what? It is crystalline in nature, and this bisulfide compound can be hydrolyzed back to carbonyl group. Hydrolyzed back to carbonyl group by adding dilute acid. By adding what? By adding dilute acid. So aldehydes and ketones undergo addition reaction with what? With sodium hydrogen sulfide or sodium bisulfite, forming an addition compound. This addition compound, it is called as bisulfite addition compound. This compound, it is crystalline in nature, and this compound can be converted back to aldehyde or ketone by hydrolyzing using what? By hydrolyzing with dilute acid. Now we can write the equation. Aldehyde or ketone means C double bond O. This is aldehyde or ketone. This compound, it is made to react with what? With sodium hydrogen sulfide. Formula of sodium hydrogen sulfide, it is NaHSO3. NaHSO3. So NaHSO3, it ionizes to form Na plus N HSO3 minus. Na plus N HSO3 minus. Okay. So in carbonyl group, carbon carries partial positive charge, oxygen carries partial negative charge. So since oxygen carries negative charge, Na plus will be added across what? Across oxygen. So intermediate formed will be like this. O becomes what? O becomes ONA. What about carbon? Carbon carries positive charge, so nucleophile should attack, correct? So HSO3 minus. See here, negative charge, it is present upon oxygen, so nucleophilic attack should take place through oxygen. Suppose if nucleophilic attack, if it takes place through oxygen, nucleophilic attack, if it takes place through oxygen, then formed bond will be carbon-oxygen bond only. Carbon-oxygen bond, which is the weaker bond. Which is what? Which is a weaker bond. Stability of this bond will be lesser. So, what happens here? Instead of nucleophilic attack taking place through oxygen, nucleophilic attack occurs through sulfur atom. Occurs through what? Sulfur atom. So, sulfur contains lone pair of electrons. Sulfur contains what? Lone pair of electrons. So, by using this lone pair of electron, this sulfur readily attacks the carbon atom. Sulfur readily attacks what? Carbon atom. So, carbon it is attacked by what? By sulfur, correct? If it is by oxygen, I have to write O first. Here nucleophilic attack, it is taking place through what? Through sulfur. So, write sulfur first. It is SO3 hydrogen, it is at the terminal end, SO3H. SO3H. So, why does nucleophilic attack takes place through sulfur? Why not through oxygen? If nucleophilic attack, if it takes place through oxygen, then formed bond will be carbon and oxygen. Carbon and oxygen. Suppose if the nucleophilic attack, if it takes place through sulfur atom, then formed bond will be carbon and sulfur. Carbon and sulfur. If we compare the stabilities of carbon oxygen bond and carbon sulfur bond, this is more stable. Carbon sulfur bond, it is more stable because of lesser electronegativity of sulfur. Lesser electronegativity of sulfur. So, carbon sulfur bond is more stable compared to carbon oxygen bond. So, nucleophilic attack takes place through what? Through oxygen atom. Through what? Through oxygen atom. In the next step, this is intermediate. Proton transfer takes place. Proton transfer takes place. What is proton? Proton means H plus. Proton means what? H plus. So, here H plus, which is present in the sulfonic acid group. This is sulfonic acid group. It contains H plus N, or it contains a proton. This H plus and Na plus will be exchange. Will be what? Will be exchange, or we can call it as proton transfer. Proton transfer. Now, why does this proton transfer occur here? See, SO3H, this is sulfonic acid. ONA means it is sodium salt of alcohol. Sodium salt of alcohol. Actually, or originally it is OH only. Now, it is in salt form. Actually, it is OH. It is in alcoholic form. If we compare the acidic nature of sulfonic acid and alcohol, alcohols are acidic in nature. Sulfonic acid is also acidic in nature. Between these two, sulfonic acid, it is more acidic. Sulfonic acid, it is more acidic compared to alcohol. Compared to what? Compared to alcohol. So, alcohols are weaker acids. Sulfonic acids, these are what? These are stronger acids. Sulfonic acid, they are what? They are stronger acids. So, if we take a strong acid and weak acid, and to these acids, if we add a base simultaneously, so in one beaker I am having stronger acid, in another beaker I am having weaker acid. To both the beakers I will add a strong base, sodium hydroxide, at the same time. So, if I add sodium hydroxide at the same time to these two beakers, stronger acid and weaker acid, salt will be formed readily, or salt formation takes place rapidly, where in stronger acid, whereas this weaker acid will form salt at a slower rate. So, between these two, sulfonic acid, it is more acidic, or it is stronger acid compared to alcohol. So, salt of stronger acid will be formed first, then it is weaker acid. Weaker acid. You can see here already OH has been converted to its salt form, correct? So, this is weaker actually. This should not happen. So, Na plus then H plus will be exchanged. Na plus N, H plus will be exchanged. So final product will be like this. ONA becomes OH, SO3H becomes SO3Na, SO3Na. So this is bisulfite addition compound. Bisulfite addition compound, and it is crystalline. It is what? It is crystalline in nature. So aldehydes and ketones react with what? With sodium hydrogen sulfide or sodium bisulfite, forming bisulfite addition compound. Bisulfite addition compound, which is a crystalline compound. Next, third reaction, addition of Grignard reagent. Addition of Grignard reagent to a carbonyl group. Formula of Grignard reagent. It is RMgX. So in the case of Grignard reagent, we can see what? R means carbon metal bond. Magnesium, it is a metal. So Grignard reagents or alkyl magnesium halides, they are made up of carbon metal bond. We know that metals are what? Metals are electropositive. Readily lose electrons. So metals carry partial positive charge, carbon carries partial negative charge. In the case of Grignard reagent, Mg it is having partial positive charge, carbon it is having partial negative charge. Now we can write the addition reaction. C double bond O represents either an aldehyde or a ketone. It is made to react with Grignard reagent. Formula of Grignard reagent, it is RMgX. I will write the polarity here. Carbon carries plus charge, oxygen carries negative charge, that is in carbonyl group. In Grignard reagent, magnesium metal carries positive charge, carbon carries negative charge. So carbon, it is the nucleophile, it will attack carbonyl carbon. It attacks what? Carbonyl carbon. So once nucleophilic attack occurs here, electrons gets completely shifted to oxygen. So it is C. Here I have tried R, nucleophile R, single bond O, electrons has been transferred to oxygen. So single bond O minus, that single bond O minus will accept positive part, that is MgX. So it becomes OMgX. Becomes what? OMgX. This is addition compound. Addition compound, also called as adduct. Addition compound, or it is adduct. Okay. So aldehydes or ketones react with Grignard reagent, forming an addition compound, or it is adduct. Now this addition compound, it is subjected to acid hydrolysis. H3O plus, or simply you can write H2O also, hydrolysis. So water from the dilute acid. I will write H2O. Hydrolysis means what? Decomposing the given compound by adding water. See, this addition compound, it contains a polar bond. Polar means polarity should be there between the two atoms. Here oxygen and magnesium, it is what? It is a polar bond. Oxygen carries negative charge, magnesium carries positive charge. Magnesium carries positive charge. This is because oxygen it is more electronegative, magnesium it is less electronegative, or it is more electropositive. So bond breaks here. Since it is a weaker bond, this bond breaks at this position in the presence of water. Water contains what? Water contains H plus and OH minus. So H plus will be added to oxygen because oxygen carries negative charge. OH minus, that is negative part, will be added to metal Mg because it carries positive charge. So I can write the product like this. It is our single bond OH. Single bond OH. So side product or byproduct formed will be, it is MgOHX. MgOHX. Now what is this? Compounds containing OH group. Compounds containing OH group, they are called as what? Alcohols. Called as what? Alcohol. So aldehydes and ketones, they react with Grignard reagent forming an addition compound. Hydrolysis of this addition compound produces what? Produces an alcohol. Produces an alcohol. Next, fourth one. Addition of alcohols, or it is formation of acetals and ketones. So aldehydes and ketones, they undergo addition reaction with alcohol. Addition reaction with alcohol forming acetals and ketones. So it is acetals are the products formed when aldehyde reacts with alcohol. Ketones are the products formed when ketones react with alcohol. Ketone react with alcohol. So first we shall explain the formation of acetal. Formation of acetal means reaction of aldehyde with alcohol. Reaction of aldehyde with what? With alcohol. Let us take an aldehyde. Say this is aldehyde. Or it is RCHO. Formula of aldehyde, it is RCHO. We can write it like this. Correct. It is C double bond O R. Here I can write H. Okay, this is aldehyde. This aldehyde, it is made to react with monohydric alcohol. Made to react with what? Monohydric alcohol. Formula of monohydric alcohol, it is ROH. Or I can write R-OH. R-OH. A catalyst is used, that is hydrogen chloride gas. So aldehydes undergo addition reaction with monohydric alcohols, or aldehydes react with monohydric alcohols in the presence of what? Dry hydrogen chloride gas. In the presence of what? Dry hydrogen chloride gas. Now what is the role of hydrogen chloride? See here, this is carbonyl compound, aldehyde or ketone. We are adding HCl. Correct. H plus then Cl minus. This is delta plus delta minus. So when a carbonyl compound, when it is made to react with alcohol in the presence of HCl, see this O, that is oxygen atom of carbonyl group, gets attracted towards what? Towards oxygen. Or this oxygen, it is protonated. So in the presence of hydrogen chloride gas, this oxygen it is protonated. Protonated means it is like this. It is OH plus. It becomes what? It becomes OH plus. So after accepting a proton from what? From HCl, it becomes C double bond OH plus. So once positive charge is developed upon oxygen, we know that oxygen it is highly electronegative. Their tendency is to accept electrons. So oxygen always carries negative charge because of protonation. How protonation occurs here? By donating what? By donating lone pair of electrons. By donating lone pair of electrons, it readily accepts H plus. Readily accepts the electron H plus. Because of the loss of this lone pair, positive charge is created. Positive charge is created upon oxygen. So once positive charge is created, this oxygen readily attracts these electrons. Starts attracting these electrons. So as a result, electrophilicity or positive charge upon carbon increases, or electrophilicity of carbon increases due to protonation. Hope you are following. See here, this is aldehyde or ketone. We are adding dry hydrogen chloride gas. What we are explaining here, what is the role of hydrogen chloride gas in this reaction? See, hydrogen chloride gas contains a proton. This is proton. So this proton gets added to oxygen. How it is added? Oxygen donates its lone pair of electrons in order to accept H plus. As a result, it becomes OH plus. OH plus. Since there is a positive charge upon oxygen, this oxygen readily attracts shared pair of electrons towards itself. As a result, electrophilicity upon carbon increases, nucleophilic attack takes place at a faster rate. So electrophilicity, once it gets increased, nucleophile can readily attack on this carbon atom. So role of HCl, it increases the electrophilicity of carbon. Increases what? Electrophilicity of carbon. So in the presence of HCl, oxygen atom gets protonated. Once this oxygen atom gets protonated, positive charge is developed upon oxygen. Positive charge, due to the presence of positive charge, this oxygen readily attracts the shared pair of electrons towards itself. Upon carbon, amount of positive charge increases, nucleophile can readily attack here. So now we can write the equation. This is delta plus N, delta minus, what about alcohol? This is alcohol. Alcohols are acidic. So alcohol ionizes to form what? To form RO minus. Acid means it should liberate a proton. It should liberate a proton. So alcohol ionizes to form RO minus, alkoxide ion. Alkyl plus oxide. It is alkoxide. Alkoxide along with proton. Since it liberates a proton, alcohols are acidic. So it liberates a proton, H plus. I can write the charge here. This is R dash. So RO, this is negatively charged. Hydrogen, it is positively charged. So alkoxide ion, RO minus, this is the nucleophile. Attracts carbon atom. Electrons will be shifted to oxygen. So we can write the intermediate. It is R, C, H. Carbon, it is attacked by the nucleophile, that is RO minus. Look here, negative charge, it is present upon oxygen. So we have to write oxygen first. It is OR dash. OR dash. Double bond reduces to single bond. O minus accepts H plus, forming OH. Forming what? Forming OH. Now this intermediate, it is called as hemiacetal. Hemi means half, or it is, what is this? OR. O means oxygen, R means alkyl group. Oxygen plus alkyl, it is alkoxy. It is what? Alkoxy. Alkyl plus oxygen. Alkoxy alkoxy. OH means alcohol. So aldehyde reacts with monohydric alcohol in the presence of HCl, forming alkoxy alcohol intermediate. Alkoxy alcohol intermediate, it is called as hemiacetal. Called as what? Hemiacetal. Hemi means only one, containing only one alkoxy group, or it contains half. So both the groups, they are not alkoxy groups. We can see only one alkoxy group. So it is hemiacetal. Hemiacetal. Okay. Now this hemiacetal further reacts. It further reacts with monohydric alcohol in the presence of hydrogen chloride gas. In the presence of what? Hydrogen chloride gas. Correct. So here what happens is, this OH group gets protonated. It gets protonated, means this OH group gets protonated, means oxygen contains lone pair of electron. It accepts H plus by donating lone pair. By what? By donating lone pair. As a result, it becomes R H OR dash, single bond, OH becomes OH2, OH becomes OH2. Due to the loss of lone pair, we have to write plus charge here. We have to write dot plus charge here. Because of the development of positive charge upon oxygen, electron starts shifting towards what? Towards oxygen. Because oxygen, it is more electronegative, it is in need of electrons. Positive charge means it is electron deficient. It is in need of electron. Readily attracts electrons from what? From the carbon atom. As a result, positive charge will be created upon what? Upon carbon. Now what happens? Nucleophile, that is RO minus, or it is OR dash, it readily attacks carbon. Readily attacks carbon, forming R, C, here it is H, OR dash, again it is OR dash. So once nucleophilic attack takes place here, this group will be eliminated, that is H2O. Water will be eliminated. Correct. So this product, it is called as acetal. It is called as what? Acetal. Since these two alkoxy groups, this is alkoxy, this is also alkoxy group. There are two alkoxy groups. So it is, since two alkoxy groups, they are present on same carbon atom. Both the alkyl groups are bonded to same carbon atom. It is called as geminal. Called as what? Geminal. If these two alkoxy groups, if they are present on adjacent carbon atoms, then we call it as vicinal. Vicinal means substituent groups present at the adjacent positions. Geminal means substituent groups present on the same carbon atom, then it is geminal. So this is geminal. Both the alkoxy groups, they are present on same carbon atom. So this is geminal dialkoxy. Geminal dialkoxy compound called as acetal. Called as what? Acetal. So aldehydes reacts with monohydric alcohol in the presence of HCl, forming alkoxy alcohol intermediate called as hemiacetal. This hemiacetal further reacts with monohydric alcohol in the presence of HCl, forming dialkoxy compound called as acetal. Called as what? Acetal. I will write the equation once again. Aldehyde, it reacts with alcohol, monohydric. Monohydric means containing only one OH group. This is R dash O minus H plus, delta plus, delta minus. So it is R C H nucleophile will attack here, that is O R dash. This is single bond OH. What is this? Alkoxy alcohol called as hemiacetal. It further reacts with monohydric alcohol in the presence of HCl. I will write it like this. This is easier. Removal of water. Removal of water takes place forming our CHOR dash. Again, it is OR dash. This is dialkoxy compound, geminal dialkoxy compound called as acetal. Name of this compound, it is what? It is acetal. So this is about reaction of aldehydes with alcohols, monohydric alcohols in the presence of HCl. Let us see the reaction of ketones with alcohols. Reaction of ketones with alcohol, or it is formation of ketones. Formation of what? Ketones. I will write the formula of ketone. It is C double bond O. Both are remaining two groups. Both are, they are what? They are alkyl groups. So it is R C double bond O R. So these ketones also undergo addition reaction with the alcohol under similar conditions. Under what? Under similar conditions, forming a cyclic product. Forming what? Cyclic product. That cyclic product, it is called as what? Ketal. Formed a cyclic product, it is named as ketal. So ketone, it reacts with dihydric alcohol instead of monohydric alcohol. It reacts with what? It reacts with dihydric alcohol. What are dihydric alcohols? Alcohols containing two OH groups. So why does it react with dihydric alcohol? Because of stability. So dihydric alcohol, reaction of ketone with dihydric alcohol produces what? Produces a cyclic product which is more stable. Which is what? Which is more stable. So formed cyclic product, it is having higher stability. So this ketone reacts with dihydric alcohol. Dihydric means we have tried two carbon atoms containing OH groups. Containing what? Containing OH groups. So this compound should contain two OH groups. So this is dihydric. To complete the valency, I have add hydrogens here. This is CH2OH. CH2OH. Name of this alcohol, ethylene glycol. This alcohol, it is called as what? Ethylene glycol. I will write the formula in the reverse direction. It is HOCH2. Again it is HOCH2. Ethylene glycol reaction, it is taking place in the presence of what? Dry hydrogen chloride gas. In the presence of what? Dry hydrogen chloride gas. No need to write the mechanism and all. So removal of water takes place. Removal of what? Removal of water takes place. So once oxygen is removed, carbon becomes, or it is deficient, correct? It becomes electron deficient due to the loss of these two bonds. Due to the loss of two bonds formed by oxygen. So those two bonds are satisfied by these two oxygen. By what? By remaining two oxygen. So we can write the structure like this. It is R, C, again it is R. Double bond, it is lost. Double bond, it is formed by oxygen. That oxygen, it is removed in the form of water, H2O. So oxygen, it is removed. So this carbon loses two bonds, or it loses a double bond. Now those two bonds are satisfied by these two oxygen atoms forming a single bond. So this oxygen forms a single bond. This oxygen also forms a single bond with the carbon like this. It is O, again it is O. Again it is what? Again it is O. Next, CH2, single bond, CH2. Here also we have to write a single bond. Now this is a cyclic compound, highly stable cyclic compound. This is cyclic product, or it is ethylene, glycol, ketol. Product it is named as what? Ethylene glycol ketol. So ketone reacts with what? With dihydric alcohol, ethylene glycol, under the same condition, that is dry hydrogen chloride gas. Removal of water takes place, forming a cyclic ketol. That cyclic ketol it is called as ethylene glycol ketol. Write the structure correctly. See, don't write double bond here. No need to write the double bond, because the double bonded oxygen it is removed in the form of water. So we have to complete these two bonds by writing single bond with remaining two oxygen atoms. Remaining thing it is same. CH2 single bond, CH2 single bond O. This is ethylene glycol ketol. So this is addition of alcohols to aldehydes and ketones, or it is formation of acetal and formation of ketol. Both the reactions are important. Explain the formation of acetal they can ask, or explain the formation of ketol. Study those two reactions correctly. Okay. Thank you.